Welcome to the June 2024 Python and Research tutorial. My name is Jamika Marshall, and I'm so pleased to welcome all of you to this first of 3 sessions this week. Starting us off will be the founder of CREST and Python and Research, Raja Guharthakurtha. Raja.
Hi, everyone. I'm Raja. I'm going to be working with some of you this summer on AST projects. But let's see. I have the pleasure of introducing this, introducing and kicking off this what we're calling 2024B, because we had a PyaR tutorial in February this year, so that was 2024A. We'll have another one in November this year, that'll be 2024C. But the 2024B tutorial, which is this current one in June, is in 3 parts, B1, B2, B3. It's non-overlapping material, in case you were wondering. So we're covering some material today, some material tomorrow, same time tomorrow. So from 10 a.m. to noon Pacific Daylight Time, all 3 days, and some again on Thursday. Again, non-overlapping material, these 3 days. They build on, each day will build on the previous days. That's how this is structured. Total of 6 hours. But if you wanted to go off and try some of the exercises on your own, you're very welcome to do that, of course. We are recording this session. I wanted to be sure you knew that. And there are at least 2 ways in which you can ask questions. You can ask questions in Zoom by putting things in the chat. But a better way, a preferred way to ask questions would be to put questions in the Slack channel. Right? And I can't emphasize that why Slack is better, can't emphasize enough why Slack is better. It's because your questions, any questions that you put in the Slack channel will stay there. And mentors can answer those questions even after the Zoom call has ended. That's not true for questions that you put in the Slack channel. Once the Zoom call ends, the questions that you've asked up to that point get recorded, but there isn't as, it goes into our recording, and it's much harder for mentors to track what you've asked and answer those questions asynchronously. So please ask questions in the chat. The other thing that has happened very efficiently in past years is students have asked questions, or participants have asked questions, and other participants who may know answers to those questions have posted answers, because as you can see, there's over 100 participants here, and there's only a handful of mentors who are answering questions. So there's a very steep ratio of participants to mentors. Speaking of mentors, I wanted to quickly go around the room and have each of the mentors introduce themselves. And if I'll introduce, I think if Maddie isn't on this call at this point, I'll introduce Maddie in any case. I'll go around as I see people. Let's start with Philip, then we'll go to Lodrick, Geronimo, and Oparajito in that order, if that's okay. Go ahead, Philip.
Hi, my name is Philip. I'm a graduate student at Ashoka University in Delhi, in India. I'm very interested in amateur astronomy. I'm not really an astronomer, but I do like coding quite a bit. And I've been associated with the PyaR tutorial for quite a while now, but I haven't been doing it consecutively. This is also the first time I'm going to be doing notebooks 1 and 2, so bear with me through this notebook. And it'd be like great to work with you guys.
Philip, you've been part of Python and Research from the very first offering of Python and Research. Before that, we were offering it in person. When we went online, that was in, I think, November 2018.
Yeah.
That's a good 6 years coming up on 6 years ago, 5.5 years ago. I remember you involved a group of students from Ashoka University in that. So thank you for being part of this. Okay, I'm going to, Lodrick, you're next by way of introduction, please.
Hello, everyone. My name is Lodrick. I'm a PhD student at the University of Santa Cruz. I work on astrophysics and astronomy research. I'm an observer most of the time. And this is my second time at the PyaR session, which is, it's been fun. I love coding and I love astronomy. So yeah, happy to have you all here. And I will be manning the Slack channel. So feel free to shoot a message directly if you don't want to shoot in the general channel, or you can shoot in the general channel for everybody's benefit. That works as well. Feel free to just ask me anything. Yeah.
And
Thanks.
Lodrick, you were part of the February session, PR session, I recall, or was it November last
I
time?
was, yes. I did notebook 3 or 4. I don't remember which one. Either
Okay.
3 or 4.
But
You did
even
3.
before that, so I think it was last year or a year before that when you were at the University of Dodoma, I know you were involved in PR as well, and you were sort of coaching some of the undergraduates there as well.
Oh,
So
yes. So I used PR material to sort of do a small little session of my own. But yes, that is, yeah, I remember that as well. Yeah, it's quite a good material for anybody who wants to give an introduction to Python.
Thank you, Lodrick. Geronimo?
Hi, everyone. My name is Geronimo, or Geronimo, or Jero, however suits you better to call me. I am originally from Colombia, but I'm currently doing my master's degree in astrophysics and space science, currently here at the Université Côte d'Azur in the beautiful city of Nice in France. So yeah, it's the first time I participate in the PyaR sessions. I'm very excited to contribute, but also exchange a lot of information, a lot of knowledge, and learn a lot with all of you. I will be mainly accompanying you tomorrow and on Thursday on the astrophysical context side of things, so you can have the conceptual tools to put into practice in the application of the notebooks. So yeah, very excited to be here.
And Hiro, you've been part of another program of ours called Shadow the Scientist that Jamaica runs, and that's how we connected.
Yes, amazing program too. I love it.
Wonderful, wonderful. Okay, thank you, Hiro, for. I'm going to pass it over to Aparajito next.
Just 1 second,
Yeah,
Raja.
please go ahead, Roderick.
Yeah, I think you were probably asking about Shadow the Scientist when you asked me about last year, right?
That's true, but you were
Okay,
also.
sorry, yeah.
You're right. It was Shadow the Scientist that you were coordinating at the University of Dodoma, not PR. You're absolutely right.
Exactly, yes.
I was confusing the two. Thank you.
Yeah. Sorry, okay.
Aparajito, you're next.
Right. Hi, everyone. I'm Aparajito. I completed my master's degree in physics from St. Xavier's College, Kolkata, India. And I have been mentoring for PyaR for a few years now. And I'll be mostly monitoring the Slack channel today, the Slack space. So feel free to post your questions there. We encourage you to post your questions publicly, and to avoid posting your questions in the Zoom chat, because once the meeting ends, the Zoom chat is gone until we upload the recording. While the Slack channel, the Slack space, you can access it anytime you want. And you can also get help from us almost around the clock, because we have members on both sides of the globe. So if you need any help with installation and stuff, please just post your questions there, post them publicly. No such thing as a stupid question. Make sure you give us a little bit of time, because sometimes we have to look up the correct answer or the best way to do something. So yeah. Also, I am a SIP mentor. I will be mentoring ASTL5. I see a couple of my interns here. To everybody else, hello. Hope to see you all at UCSC this summer. Okay, over to you, Raja.
Thank you, Aparajito. And I just wanted to give a shout out and an introduction to Madeline Broom. Maddie is a PhD student at the University of California, Santa Cruz, the same department as Lodrick, UCSC. Maddie has been part of the Python and research tutorials for a couple of years, a few different sessions, and she helped put together a set of slides explaining how some basic facts about stars, and that I think she's on track to present those tomorrow, I think, Jamika, if I'm not mistaken.
That's correct.
Okay, so Maddie will get a chance to introduce herself, but I just wanted to point out that Maddie will be on the mentoring team and will be you'll see her tomorrow. I'm going to take a couple more minutes. Is that okay, Jamika? Am I running behind?
Well, we're 15 minutes in, so we can be flexible.
Okay, I'll take 5. So I'm going to show you. I'm going to actually share why this Python tutorial may be important to you. Even if you've never programmed before, please reach out in the Slack channel and ask about how to get Anaconda Python installed on your computer. It's a free installation, but there is a specific channel for Python installation. If you're a seasoned programmer and you have Anaconda Python going, even then we'll have elements of this tutorial that will hopefully bring new information, bring new challenges to you. So it's really for everyone from a beginner to relative expert. If you're a relative expert and you want to post answers to questions that other people ask, please feel free to do that. And I just realized that Anand, if you wanted to say a quick word of introduction, please do. I don't know if Lindsay is on as well. I didn't see her.
Hi, everyone. Thank you to all 145 of you for joining the first PyaR session. It's great to see everyone. And also, Andrea Rosas is on the call. She wants to say hi. She'll be our CRE
Hi,
in-house
Andrea.
this year.
Hi, everyone. Thank you for joining us.
Back to you. You guys are doing great.
CRE is the coordinator of residential education. So Andrea will be the point person for everything related to housing on the UCSC campus. There are many ways to learn computer programming. There are many places where you can learn Python. I wanted to say a couple of things about what makes the PyaR tutorial, what is special about the PyaR tutorial. It may not be unique. There may be other Python tutorials out there that offer these same things, but I wanted to list the things that make that are definite features of PyaR. One of them is, of course, this is a tutorial that helps you learn about coding in general, Python coding in particular, but we'll be using something called Jupyter notebooks, which are a browser interface for Python code. Browser meaning when you fire this up, your favorite browser, whether it's Safari or Chrome, will open up, and you'll get to see the Python code in your browser rather than in a separate application or a separate file. It'll be in your browser itself. You'll see the code. And the beautiful thing about notebooks is not only do you see the code, you see the results of the code. When you run the code, and if your code is supposed to do a calculation and print out some number, that gets printed on your browser screen as well. If your code is supposed to generate a plot, that shows up on your browser screen as well. In the old days when you were programming, there were separate apps to edit the code versus see the output of the code. That's all integrated into your browser when you're using a notebook like Jupyter. So you'll learn Python programming. That's one of the goals of this tutorial, to learn Python programming using Jupyter notebooks. The other thing you will learn in this tutorial, and some of that will be later today, but when I think Aparajito presents this, is you'll see the structure of a scientific journal article. We'll use a particular astronomy research article from 2015 to illustrate from 9 years ago, but journal articles are across different disciplines, have a lot in common. So you get to learn about that a little bit, about how scientists publish their research. Publishing looks different in the humanities and social sciences, or even engineering. So the example we are using is from astrophysics. A third thing that you'll learn, and this may be more important to some than others, is there'll be some very basic astrophysics concepts. How stars evolve, how they are born, how they change over their lifetimes, and how they die. Something called Hertzsprung-Russell diagrams or color magnitude diagrams. This is a useful tool to study stars. We learn about a spectrum or spectra, plural of spectrum. We learn about the phenomenon of Doppler shift. We learn about some features of galaxies, how disks move, how the dynamics of disks, how galaxies form and change over time. And the change involves collisions or mergers between galaxies. Now, again, that will be relevant to those who are in astronomy research projects in SIP, but it may be of interest to others who are in a different research area, and there may be people on this Zoom call who are not connected to SIP at all, who may be interested in astronomy research. So that third thing, which is astronomy research, will be more important to some than others. You'll learn some relevant mathematical and statistical concepts. Logarithms, standard deviation are examples. And those, of course, transcend astronomy. I think the most important aspect of PyaR is, I've saved that for the last, is these explanations that you'll hear via Zoom, whether it's in the chat or video and through Slack. These explanations are coming from people who are directly involved in this research and astrophysics research in general. So it's not that we are talking about the research that's done in other fields. This is research being done in our own fields. We are the ones who are doing, the mentors are the ones doing this kind of research, and we are presenting this to you. So again, 5 things. You learn Python, you learn about the structure of a scientific journal article, you learn some astrophysics concepts, you learn some math and statistics concepts, and you learn this from people who are doing the kind of research that this notebook is based on. Aparajito, I assume when you talk about Claire's article, you'll talk about how this tutorial was constructed from code that was actually used for that paper. So I won't go over that now.
Yeah.
Were you going to show any Andromeda slides, Aparajito, or can I? I'll save that for tomorrow, perhaps.
Yeah, I don't think that's on the schedule today.
Yeah, I might try to do that tomorrow. I'll hand it over to Philip now. And Jamaica, unless there's anything else you wanted me to say.
That's perfect, Roger. Thank you so much. All right, Philip, let's get us started with notebook 1.
Right. So everyone can hear me clearly, right?
Yes.
Yeah, perfect. So I'm just going to share desktop 1. Just give me 1 second. Yeah. Can everyone see my screen?
Sorry, Philip. While you get started, let me quickly jump in and tell everyone that if you're trying to install Anaconda during this tutorial, please know that you don't need to do that right away. We have set up the whole tutorial so that you can go back and watch the recordings. So, just feel free to grab a notebook and a pen and just take some notes. You can install it later and run all this code by yourself. Okay? We will make sure that you can run everything. If you have any questions, please post them to the Slack channel, and we'll get back to you. But you don't have to be busy. You don't have to keep an eye on the installation and the tutorial at the same time. So yeah, over to you, Philip.
Just give me 1 second. My Zoom bar is misbehaving. Okay, great. So everyone can see my screen. Yes, I'm going to start talking about the first notebook. And the first notebook, we're not going to be talking too much about astronomy or astrophysics. We're just going to be talking about how we can use Python to do certain basic tasks that are perhaps too tedious for what you would want to do on your own. Okay. So we're going to go through some very elementary things, and then we're going to try and see how we can use this to actually deal with scientific data in the next few minutes. Before we start, here at the top of the notebook, we have a bunch of resources that people can use to learn about Python. You can read the documentation here. There's an official tutorial that you should go by and take a look at, and chapters 3 and 5 are useful there. And there are some other resources here, including Stack Overflow, which is the sort of place that anyone who's doing any sort of coding will eventually end up. It's a very good resource of a large extent. So we'll be using Python 3 here, which is Python 3.6. I think my version isn't Python 3.6, but you probably wouldn't notice it for the simple stuff that we're doing. So just make sure that when you download your Anaconda, you're downloading the Python 3 version and not Python 2 versions. And I think all the links should be fine. And what you're seeing right now on my screen is Jupyter Notebook. So it's this interactive notebook, as Raja was describing, where you have input cells and output cells, and you can type things out in input cells, as I'll show you, and they will show up in the output on the notebook as well. And you can have interactive outputs. You can have outputs with graphs, with text. You can move around in the graphs. You can do lots of interesting stuff. And we'll be doing some of that later on in these sessions. So this is a browser-based notebook. Just to point out, this is not running on the internet. It's running on your computer. It's just that it's running in a browser on your computer. So you don't need the internet to run this, although you probably need an internet to connect to this call. So now let's move on to the first cell, which is sort of historically the first thing that most people do when they code, which I find very surprising, but and a little boring. But let's do it, and then we'll move on to more exciting things afterwards. And the first thing is to print out the word "Hello World." This is the first thing that everyone does when they're coding. And many years ago, when I started coding, this was the first thing I did as well. And so what we're going to do is we're just going to write out the following sentence that I've written down here, which says print hello world. Okay, so let me just write it out in front of you. Let me just remove this. So what we're saying is we're calling a function, which is an inbuilt function in Python that prints something on the screen. So I'm just going to type out print, and you see that the color's changed, and it should have changed for you as well if you type this out, because this is a Python keyword that Python recognizes, and it understands that you want to use the function called print. So you'd ideally not want to use different variable names and so on that have these sorts of keywords. And what we're going to do with this is we're going to write two brackets here, and we're going to write in the word hello world. Exclamation point. So these two quotation marks that we have on either side indicate that this is a string. In other words, this is a string of characters that we're going to treat like one combined block of words, and we're going to print this out. Okay. Now that I've done this, if I just leave this as it is, nothing's going to show up underneath it, right? And in order to run this cell, well, you can just click onto the cell and then go up here, and you can press the run button there. Or you can do what I really like, which is to press Shift and Enter together. And that's what's described up above here, that when you want to evaluate a cell, you run Shift and Enter. So I run Shift and Enter here, and you'll see that immediately after I run it, two things happen. Number one, the number here becomes number 1, meaning that I've run this cell the first time. And underneath that, you have the words hello world that show up because it's printed the words hello world here. Okay, so I could, of course, change this to say hi, for example, and if I ran that, it would just print out hi. So this is a dynamically changing output that will keep changing every time you change what it is. Great. So, and notice that when I ran the cell the second time, the number here just tells you that it's run again. So this is just the order of execution of the cell. So it'll tell you which cell has been run before which other cell. Great. So the point is that this doesn't seem like it's very exciting, and that's because it shouldn't be. It's a very simple thing to get the computer to print something out to you. And in most other programming languages, this is quite difficult to do, or at least a little bit more involved to do. So when I started coding in Java, which is this syntax that you see over here. It's a very complicated thing to just print out the words hello world. So the point is that Python is quite simple and it's very powerful. It allows you to do different things. Okay, so now let's just go on to using it to do simple calculations. Okay, and you can read through this at your own time about how you can use Python to do different things. One important thing to do is to add something called a comment. So I'm going to do that down here as well in a few minutes. But let's start off by trying to use Python as a scientific calculator. Okay, and everyone should understand what this means. It's sort of it reads as it should read, in the sense that if I have two numbers, 2 and 2, and I want them to be added to each other, all I need to do is say 2 plus 2. Okay, and if you just see that I've written that here, it takes the number 2 and adds it to the number 2. And if I press Shift and Enter right now, it's going to execute this and it's going to print it out immediately after. Notice that I haven't actually said the words print, because Python understands that if you just have a command in a cell, then it's going to print out the output onto the cell. But if you want it to be a little more proper, you should technically write the words print around this if you want to be a little better with your coding. And if you type this out, it just prints out the number 4 right here. Okay. And I could now add a comment, which is, yes.
Philip, sorry. I
No
think
worries.
your video is frozen, like the screen share. Can you please reshow your screen?
Do other people have the same problem? I can stop sharing.
Yeah, I think a lot of people are.
I'm still seeing the hello world line.
Oh dear. Okay, I'm so sorry. I don't understand why that's happening. Let me just stop and start again.
Okay.
Let me just share my entire desktop. Maybe that'll help. Is this better? Can everyone see this now?
Yeah, your cursor is moving, so I think that's good. Yeah.
Just keep an eye out for that. Let's hope that this doesn't happen again. Okay. Right. So just to recap, what I was doing was printing out the sum of 2 and 2. So I added 2 plus 2. And I put this inside the print function, which accepts whatever I send into it and prints it out on the screen. I'm also going to write a little comment here that says add 2 to 2. So notice that the minute I put a comment sign over here, this thing changes color. And basically what this sign tells Python is just ignore everything to the right of this. This is just something that you have put in there for yourself to just make sure that you know what you're doing later on. Okay, so we're going to comment our code well from time to time, because it's going to be very helpful for us to go back and look at old code and figure out what exactly we were doing. You can often forget what to do. Anyway, so this is addition, and now I can of course do subtraction by using the minus sign. And if I did print 4 minus 2, for example, and I ran this, I would get the answer 2 here, right? So we could just say subtract, put a comment here that says subtract 2 from 4. And similarly, I could do multiplication. Now notice that multiplication in Python is done with this little asterisk over here, which is basically the on the standard US keyboards, it's the little symbol above 8. So you can do this by pressing Shift and 8. And if I ran print 4 times 2, then of course I will get 8. There you see. So we've used Python as a basic calculator. We can also, of course, do division, which is the 4th operation right now, where we have division being denoted by this little slash that does 4 by 2. So divide 4 by 2. If I ran that out, I get 2.0. Now you'll notice something interesting happening here. So in all of these numbers, you just got 4, 2, and 8. But over here, you get 2.0. Now the reason you get 2.0 is because this is what we call a floating point, or a decimal number. And Python is a very smart programming language. It knows that when you add two integers like 2 to each other, then you get an integer, which is 4. It knows that when you subtract 2 integers, you get an integer. It knows that when you multiply 2 integers, you get an integer. But it also knows that when you divide 2 integers, you don't always get an integer. So in principle, you can get a decimal or a floating point number. And therefore, it sort of tells you that the answer is this decimal number, 2.0. The last thing that we could do is, and which we will find to be useful, is to raise something to a power. So for example, we could raise 4 to the power 2, which is equivalent to saying 4 times 4. And if I wanted to print that out, just to print 4 to the power 2, notice that it's different from the single asterisk over here, which we use for multiplication. It's 2 stars. So if you do 4 to the power 2, we'd get 4 times 4, which is 16. We did 4 to the power 3, you'd get 4 times 4 times 4, which is 64. Right? So notice that this is not the little carry symbol over here. That actually means something else in Python. If you don't know why one would use this carry symbol, don't worry about it. But if you do know it, just make sure you don't make the mistake of putting this little hat. What you should be doing is putting 2 asterisks like we've done over here. Okay. Any questions so far? Is everyone okay with this? We've just gone through basic mathematical. I'm sure there are many questions on Slack and in the Zoom chat. So, but if anyone wants to unmute themselves and ask a question, that's fine. Otherwise, we can move on.
Hello. Yes, I have a question.
Yes.
Is there a difference in putting a space between the times and the for or the
No,
division?
no. There's no difference
Okay.
between spaces.
Thank
So
you.
you could add any number of spaces. And in fact, you should add some spaces for readability, but not too many spaces. Like this is obviously not going to be very readable. But it's just an aesthetic choice. It's not very.
Okay, thank you.
Any other
Yeah,
questions?
just don't put spaces in the middle of a variable or a command name. And the number of spaces will matter when we reach loops. Yeah, that's for later.
Okay, great. So there are no other questions. Let's move on to how we okay, and let's actually do something a little bit more complicated, which perhaps might be useful.
Okay, Philip, there was a question in chat.
Sure, go for it.
Is there a specific order of operations for Python?
Very good question, and we're going to go to that right now. That's exactly what I'm going to work on. Any other questions? Okay, so let me just start off with the order of operations question. Now, first of all, I don't want to run this right now. I'm going to run something else. So I'm just going to comment out this. Now, I can comment out it by putting that little hash mark in the front of this, and you notice that it's changed color. But there's another way to do it, which is to comment out by pressing either Control or Command, depending on whether you're using Windows or Mac, and the slash button. So I could see, I'm just writing out a note here saying comment text by typing Control plus slash, or you can also type out Command plus slash, depending on whether you're using a Mac or a Windows computer. So that comments out this entire line of text. Great. So let's come back to the question of the order of operations. So let's say I want to do the following thing. I want to add 1 plus 2 divided by 3. And in my head, I know 1 plus 2 is 3. And I divide it by 3, and I should get 1, right? But if I run this, you'll notice that I don't get 1. I get a strange number. I get 1.66666. And the reason for this is that Python has a certain order of operations. And so what it's going to do is it's going to take 2 by 3, and it's going to evaluate it first, okay? And it's going to find that 2 by 3 is equal to 0.66666. And then it's going to add 1 to that, okay? And so the order of operations does matter. And if you want to preserve a certain order of operations, then what you'd want to do is put the terms that we were interested in parentheses. And therefore, that's telling Python, okay, you add 1 plus 2 together first, and then divide the answer by 3. So you should be using your parentheses in the right way. Does that answer your question? I mean, I hope that answers the question. And you see that if you run this, you get 1.0. And of course, we can make this very interesting. You can then go on to say plus 4 to the power 3 and so on, and run this, and you get a different answer. Great. So far, we've just used Python as a calculator, which is not at all using it to its full potential. So what we now need to do is actually move on to start seeing what we can actually do with Python. And before we do that, we can't just deal with numbers. We need to start dealing with variables. In other words, we would like to assign these different quantities to each other. Yes, Jenny.
Okay, just a few questions in the chat.
Yeah.
First from Calvin, how would you get an answer as a fraction instead of a decimal?
Very good question. You can't, sadly, as far as I know, at least not using the standard Python packages. There is a package called SymPy that's quite useful to get symbolic answers, but I don't think that you can do it with the standard Python. It just gives you a floating point answer.
Thank you. Okay, and so next, the question is, why didn't you write print in that?
Very good question, because I was being sloppy. What I should be doing, you're completely right, is to write out print and this. It's just that it's not needed. Let me show you why, where it would be. So for example, let me do the following thing. I do 1 plus 3, and I run it, and it just prints out 4. It prints out the last thing that I wrote. But if I wrote immediately under this, if I wrote 2 plus 4, if I wrote 2 plus 4, you'll notice that you might imagine that it would print out 1 plus 3 and then give you 4, and then it print out 2 plus 4 and give you 6. But if I run this, you'll notice that it only gives me 6. In other words, all it does is print out the last evaluation that it has actually evaluated, last thing that it's evaluated. So if I ideally want to print out 4 and then 6, then what I should be doing is writing print this, then print this, and then you see that you get 4 and 6 right on.
Excellent. And the last one, what if you divide by 0, Philip?
Let's try it. A lot of these questions we can actually find out by trying it out ourselves. So I do 1 by 0. It's a very good thing to do. Try it out, and we say that it gives you a very usefully named zero division error, which is that you're trying to divide by zeros. Python's basically telling you don't do it. Right? Any other questions? So a lot of these things you should try out yourself. So, I mean, nothing's going to explode. You're not going to destroy anything. Just try it out and see what happens.
Yeah,
Okay.
and let me address the comment and build on what Philip said. Somebody mentioned it doesn't compile. Please note that Python is not a compiled language. It is something called an interpreted language. So it's basically a bit like compiling on the go, in a sense. So, that's actually a huge advantage of Python, which makes it really easy to work with. Doesn't make it as fast as some compiled languages, but it makes it really, really easy to work with. So exactly like Philip said, it won't break your computer. It won't ruin anything. You can just edit that exact cell and run it again. So yeah, that's a huge advantage. And somebody asked if you can run Jupyter in VS Code. Yes, you can. You can also run Jupyter, or at least the notebooks on Google Colab if you want to use that. But you have to figure out how to upload this data and mount the directories. So yeah, those two are your alternative choices to using Anaconda distribution and Jupyter Notebook. Yeah, over to you, Philip.
Great. Okay, so now we're done with basic stuff. We've seen how we can work with numbers. But of course, before we can do anything more interesting, we would like to move to variables. We'd like to deal with large numbers of numbers. We don't want to just use Python like a calculator. And before we can do anything else, we need to learn how to assign a number to a variable. And we do that using the assignment operator, which is given by the equal to sign. So just remember that this is not an equal to in the sense of mathematics. This is more an assignment operator. In other words, what we're saying in this particular line is that we're taking the number 1 and we're assigning it to a variable that we're calling A. Now we're taking a number 2 and we're assigning it to a variable that we call B. And then we're going to print out A, and then we're going to print out B. Okay, does everyone understand this? I hope everyone understands this. So if I run this, you should see the number 1 and the number 2 immediately after. We can also make the print statement a little bit more elaborate. And I could type out, for example, the variable A is, and the variable B is. And notice how I put these little commas here. So what this is going to do is it's going to tell the print statement, first print out the variable A is, and then print out the value A, and do the same thing for the variable B. Yes, Jamika.
Yes, thank you, Philip. Okay, so Nathan appears to be having trouble opening the files on the Jupyter page using the Chrome OS. Is anyone else having that issue? And if so, can you give us some guidance?
I've never used Chrome OS myself, so I think the best thing to do here would be for him to go on to chat, and maybe Aprajito or the others could help out with that. I think that would be easier
Yeah,
because with screenshots,
please, people, direct your questions to the Slack channel. There's a dedicated Slack channel called installation. That's where you should post this. Ryan, also please post your question to Slack. Yeah, it is easier for us to get to the questions if you post them on Slack.
Often it's very helpful to have a screenshot.
Yes.
So it would be nice to actually, that Slack allows you to do that. So that would be a very helpful thing.
Yeah, it is. Yes, Slack is
it's a free software, just like everything else in this tutorial. It takes 2 minutes to make an account. You don't have to install the software. You can use Slack from your browser. So yeah, please post your questions to Slack.
Yes.
What's Aprajito? I sent the link in the chat for the general channel, but can you drop the link to that specific channel you're asking them to post their questions in, please?
Yeah,
Thank
sure.
you. And while you're doing that, Zoe says they cannot get on Slack, create a Slack account, but it isn't letting you in. Okay, let's try that. Okay. Will you try that again for Zoe? And then if not, direct message me and I'll see if there is an issue that I can help you with. And another question, so back to Ryan, does it matter if a block or cell number changes, excuse me, when making edits to the code?
No, it doesn't. In the sense, it will in fact change. You notice this particular cell, we didn't run it, so it doesn't have a number. But this particular cell is 14, so we've run it 14th. So if I keep running this again and again, getting exactly the same answer, you'll notice that its number is just going to keep incrementing. So this is just a sort of guide to the eye to let you know which cell has been run before which other cell. So you know, for example, the fact that this is 20 means that it was run before this cell was run. And that's all we need to worry about. So that number really doesn't matter except to debug and say, okay, which cell have I run in which order have I run?
Right. Sorry, Philip. Once again, to cut in for a second. I'm sorry, I can't share the invite link to that installation channel, Jamika. I don't know how to grab that link for that specific channel, but if you join the Slack space with Jamika's link, you should end up in the general channel, and there I have pinned a message describing everything that you need to do to install and everything else that you need to do before you start this tutorial. And in that very message, I have mentioned the installation channel. You can see that it's highlighted in blue, like hyperlink. If you click that, from that message, it will take you straight to that channel. And if you can't find it, it is completely fine. Just post your questions to the general channel. We will not mind. Okay? Do not worry. We're here to answer your questions.
Great. Shall I move on? Do we have any other questions for me? You're muted.
Thank you. Let me just point out, yeah, so if you, I just dropped the link to the general channel, the Slack channel again. And as a project to say, you can put your questions right there. If you're still having issues, some people said that they just joined using the mobile app, which is what I had used also, and I didn't have any issues. So I'm so sorry about that. I apologize. If you attempt to download the app and you're still and you download it and you still aren't able to join, please let us know. And thank you all who are adding some very helpful comments on guidance on this issue. Yes, and I will drop the link again to the to Slack here. Yes, got it. It's coming right now. Okay, and yes, Philip, we did have another question, but I think someone answered it, but I'll go ahead and ask it again. How do you print quotation marks in a text? Oh, we can't hear you, Philip.
Yeah, I just realized it. Zoom conveniently told me as well. So that, as far as I remember, there are two ways of doing it. So of course, if you had a text saying, I don't know, Philip said hi, then of course it's going to be a problem, because you notice what's going to happen here is that it thinks that this string ended here, and then it thinks that there's a new string starting here. So that's not going to work. So what you could do is, of course, change these quotation marks to the other single quotation marks. Just a second. So see what I've done here. I've done Philip says hi in the big quotation marks, and I've used little quotation marks inside, and that Python is smart enough to print them out. If you want to be a little more complicated and you want to use the double quotation marks, then you will have to use something called an escape character, which is to put, I think, a slash before and after this. Let's see if this works. There we go. And we get Philip says hi over here. So if you want to use, you could change your quotation marks, which would mean that it would be very simple to print it out. On the other hand, if you do want to use exactly the same quotation marks, then you should put an escape character, which is basically telling the code that whatever comes after the slash is the actual quotation mark character and not what it means in Python. So we call that an escape character. Does that sound okay? Yep.
Yes.
Great. So let's move on then to the next cell if we're okay with this. Okay. So now what we can do is, great. So what we saw was that we could assign a number to a variable, and then we could use that variable. We could print it out, for example. But of course, we don't want to just assign numbers and print them out. We want to perform mathematical operations on them. And we can, of course, start off by assigning and reassigning numbers. So that's what we're going to do in this cell here. So over here, I set the value of a to be 1 plus 2. And then I could just print out what the value of a is. I could say the value of a used to be this. And then I could reassign it to the number 27. And then I could say the value of a is now this. And if I run this, you'll see that the value of a used to be 1 plus 2, which is 3. And the value of a now is 27. So every time I run this cell, it's going to reassign a to first 3. And then it's going to assign 27 to a again. And it's going to just keep doing this. And of course, you can keep changing this over time. So this variable a is like a container, and you can put what you want into this container, and you can keep changing what's put into this container. And of course, we can now use this to actually start performing some operations on these variables. So we can start off by saying a is equal to 1 and b is equal to 2. And we can, of course, add these numbers together very simply to get 3. And that's exactly what we see here. Does everyone understand this? I mean, this is very simple stuff. If there are any questions so far, you should let me know. Otherwise, we can... Great. And so far, we've been using things inside a single cell. But of course, that wouldn't be very helpful. We would ideally want to use things across multiple cells in our notebook. And we can, in fact, do that. So notice that in this cell, we haven't defined A and B. A and B have been defined above. And when I run this right now, I'm going to print out the values of A and B, which are in the previous cell. So you can use this in any cell much later. Okay. Great. So you shouldn't, I mean, ideally, you should not be writing one line in every cell, but you also don't want to be writing huge blocks of text of code in each cell. So you need to find the balance, and you'll see that balance as we go through the later notes. Yes, Jenny.
Yes, thank you. Okay, so there's several questions, some about Jupyter Sheets. And so I just responded in the chat that if you were able to get in the Slack channel, PyaR Gito can help you with those issues there in the Slack channel. Okay, so question here, which I think someone has helpfully answered, but I'll bring it to you as well, Philip. What do you do if you don't want a space after the colon and before the value there? And thank you all again for all of the helpful responses. I really appreciate all the engagement. Thank you so much.
Right. So let's say I had the following line, right? And if I run this, you see that there is a space automatically added here. Now, if you don't want the space to be here, what you could do is this print function, as you can see, it accepts different parameters. So it accepts different variables. So it can accept a string, this is the sum. Then it can accept a number and print that out. But it also accepts certain optional parameters. And I think that this parameter, someone correct me if I'm wrong, is to say end, I think that's right, is equal to this. Now let's see if this runs. Does it work? I don't remember exactly what one could do here in this particular case, but you could do something else. You could do the following thing. Notice how I've removed the comma. I've just put in a plus sign here. I've said this. So now what we've done here, it looks like a little bit of a complicated statement, but this will do exactly what you want. Notice that there's no space here. So what we do here is that we take the first string, this is the sum, and we add it to another string, right? So what we do is we first evaluate a plus b. So Python evaluates a plus b, finds that it's the number 3, converts it to a string, and then adds that string to this string. And I think we'll be studying about how we add strings together a little later down in the notebook. But this is what we're doing in this entire line. And now we can decide how many spaces we have after the colon, because if we run this, we see that there are large number of spaces here. I hope that answers the question. There is a way to do it using the end option as well. I just don't remember what it is, right? Any other questions, or should I move on?
Please continue. That's all good.
Right.
I'll raise my hand if there are any other questions. Thank you so much.
Fantastic. Fantastic. Okay, great. So let's now actually try and perform some other operations by changing our variables. Well, one thing we could do is, of course, we can assign A to be a specific variable, say 1. And then we could perform this strange operation, which is called the increment operation on A. And this weird notation over here, which is the plus equal to notation, is the same thing as writing A is equal to A plus 1. Now, this looks like it's very strange. I mean, if someone looked at this and saw that A was equal to A plus 1, you might be tempted to cancel out the A on both sides and find that 0 is equal to 1. But of course, as I pointed out, equal to is not an equals operation like you're used to in mathematics. This is more an assignment operation. And so many of these sorts of commands in Python should actually be read right to left. So what this entire line basically means, take the value of A that used to be A, add 1 to it, and then store that in the variable A again. Okay. In other words, take A, add 1 to it, and give it back and put it back in the container that's called A. This is called incrementing A. You could also do A is equal to A plus 2 by saying, for example, let me just write that. If I did this, A is A plus equal to 2, that would be equivalent of saying A is equal to A plus 2. You could also do the same thing for multiplication. You could do A star equal to 3, which is the equivalent of saying A is equal to A into 3. And if I run this now, you see that 1 is printed out because that's what A is. And then 1 plus 2 will give me 3. And notice that A is now equal to 3. And therefore, in the next step, where I do A into equal to 3, that means what you're going to do is A is equal to A into 3. You take 3, you multiply it by 3, you get 9, and you store that in the variable A. And that's what we get down here. Right? So these are simple mathematical operations. Just keep in mind that when you perform an operation like this, you're actually changing the value of A. And since you change the value of A, that value is going to go down further in this cell as well as later on in the notebook. When we print A in any other cell, it's going to remember that the value of A is now 9 until we reassign it to some new value. Great. So now we come into strings, which was the question that someone had asked before. And we can manipulate a bunch of strings together to do a lot of interesting stuff. This is going to be important, for example, when we make our plots, when we have labels, when we want to do different things with them. So we could start off by defining a certain string, say S, and we could call it hello world within quotations. So this is a string because it has quotation marks on either side. And we could either print S, and then you notice that there are some inbuilt functions immediately after this. And what I'm doing, let me actually run them one by one. Just yeah. So what I could do now, if I just run print S, I would just get hello world up here. Great. But now I could do something else. I could print S dot lower. Now this means these are called methods. In other words, they are inbuilt functions within strings which can perform certain operations on the string. So what this does is it takes the string, hello world, and converts it to lowercase. And these little parentheses that you see after the word lower are a sign that this is actually a method. So most methods, so many methods can actually take in parameters and give you output based on those parameters. But some functions or methods like lower, for example, don't accept any parameters. So in this case, but you still need to put the parentheses around. So when I run this right now, it's going to convert the string hello world all to lowercase. And you're going to see that immediately down. Yeah, see, it's the H and the W have become lowercase. So similarly, you could also print out s.upper, which would print out an uppercase string, exactly as before. We'll see hello world. So it sounds like your computer shouting at you. And then you can also do interesting things. You can also print out S. You could also try to replace. There are other functions within that the string possesses, other methods that the string possesses. And what you could do is you could replace the word world, for example, with the word, what do I put? Okay, so you could say hello universe, for example, because we're going to go to astronomy. So let's just run hello universe. And what this does is it replaces, it looks through the string, it finds the word world, for example, and it replaces it with the word universe. Okay. And you could, of course, you don't really need it to be an entire word. It can just be a string of characters as well. So for example, you could just choose these 3 characters, and just you could put them down here, and you could replace them with some strange set of characters. And if you ran this, it would just replace all of those characters that you originally had in the text with this new string. So this just allows you to manipulate strings together and perform different operations. And these are very useful things. It sort of shows you how versatile Python is and how easy it is to do these tasks that in other programming languages would be relatively difficult. These most programming languages would be quite hard. You can also add strings together. So this is called concatenation in slightly more advanced terms, but basically you can think about it as just adding 2 strings to each other. Yes, Jamika.
Okay, so for those asking about the completed notebooks, I'm going to drop a link. I thought we had like separate kind of blocks of the completed notebooks, so we have the recording. So I'll drop notebook 1, 2, 3 separately in the chat here in just a moment. And yes, thank you, Anand, for answering that. Again, yes, the recordings will be shared with everyone. Once this session is done, I will send a link to the edited recordings, excuse me, to everyone who attended this session. Anand will also have it, and I think we'll post it on the PyaR website. It will be posted in the Discord also, Anand says, so no worries. Okay, and then a question. Can we, instead of making the letters uppercase, instead of doing that, can he only uppercase the starting letter of each word if the string doesn't have uppercase letters at all? Is that yes? And I believe we have a response there too, but can you speak to that, Philip?
I don't completely. Yes.
Sorry,
go ahead.
so sorry. But Jamika, I have shared the Google Drive link, the empty notebooks in that message thread. I think it has all the notebooks. So everybody who asks for it, please click that link, and it will take you to a Google Drive page. You'll see a download icon somewhere to the top right. Just click it, and it will download a zipped folder. You will have to unzip that folder, and you'll get access to all the data, all the notebooks, and all the scripts. Okay, that should have all the empty notebooks. The completed notebooks, I believe we shared them at the end of the tutorial. But for now, the empty notebooks are all you need. Yeah, over to you, Philip.
Right. Okay, so here's something. I don't actually know how to do this, but I'm going to try and see if I can figure it out. And I'm going to show you how one would figure it out in Python, because Python is such an intuitive language. So when you say that you want the first letter of every word to be capitalized, what you're essentially saying is that you want title case. So that's what this is called. This is called title case. You want it like a title of a chapter or something. So it's not lower and it's not upper. So let's just check whether there happens to be a function called title. Now you can do that by typing out the string variable s, placing a dot, and then pressing the tab key on your computer. So when you press the tab key, it gives you a list of all the different functions that you have within the string, within the options that the string possesses. So one thing you could do is, of course, there are a large number of them, but what you could do is just press T, and you see automatically that we've sorted things and we've filtered things, and we see that there is a function called title. Okay, so let's press enter here, and then we'll say, okay, I don't know what this function does. Okay, so I put a little question mark at the end of that. And I'm asking Python, okay, what does this do? I think I'm asking Jupyter what this does. So if I now run this, I think this may not work in other IDEs like VS Code and stuff, but it definitely works in Jupyter Notebook. If I run this now, you'll see that it opens up this little pager at the bottom here, and it tells you what s.title is. It gives you some documentation on s.title, and it says that it returns a version of the string in which each word is title case. More specifically, when words start with the uppercase letters, blah, 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 and so on. You can read through this yourself, and it tells you exactly that it is, in fact, what we want to do. So we can now close this little pager here, and then I can just run s.title, and you see course, since it was already in title case, that's not going to help us. Let's try a new string right now. So let's say new string is equal to, this is all lowercase. And I could now do new string title. And you see that this is converted into title case where the first letter. So yeah, so it's not something that I knew immediately, but you see that you can actually find out what functions to use by just sort of using some amount of common sense, and Python is quite intuitive. Were there any other questions, Jamika, or should I move on?
All good. Thank you.
Fantastic.
Well,
Okay, so
I was
yeah.
going to say there was another question about how do you make only the first characters lowercase and the rest uppercase, but I believe it was answered that it was answered in the chat. But if you'd like to speak to that as well, please.
I have no idea how to do that, but we could figure it out. But I think we should move on to doing other
Okay,
things.
it sounds good. Thank you.
Yeah.
Okay.
Please Google it. Google is your friend. And like Philip said, Stack Overflow is your best friend. If you can't find it on Stack Overflow, try Googling with different keywords with a different description. And if you really, really can't find it, then you have reached a certain level of coding where you are encountering problems that nobody has. But yeah, please Google it. It's a fun exercise.
Great. So now down here, which I'm going to show you how you can do different types of operations on strings. So we could do something like adding two strings together. So this is not the same as adding two numbers, obviously. But you shouldn't be too surprised by what we're doing right here, which is we're taking the string S and we're adding to it the letter, we're adding the string "It's a beautiful day," for example, to this, right? So if I run this right now, what it's going to do is it's going to take the string S, which if you remember was "Hello World" up here, and it's going to add to it the string "It's a beautiful day," and it's going to print the answer out. So I'm going to do that, and you say it says "Hello World, it's a beautiful day." So this is quite obvious. So this is concatenation where you add two strings to each other. But of course, you could also do something a little stranger. You could do this. You could take a string and multiply it twice. Now you might be a little confused as to what this does. So what it means to multiply a string by the number 2 is actually to make two copies of the string. In other words, to add it twice. And in this cell, when I run this right now, you're going to see that it's going to first print out "Hello World, it's a beautiful day." And then it's going to take the string S, which is "Hello World," and it's going to multiply it by 2. And when I run this, you're going to see it says "Hello World, hello world," right next to each other. If I multiplied it by 10, I would get many different hello worlds, one after the other. Right? Does everyone understand what we've done? So it's just, you can make copies of strings this way. Jamika, are we doing good for time, or should we move on to the next? We can move on to Prajito's part, and then I can come back and do lists and NumPy arrays and the other thing in the next 30 minutes. Is that okay?
I think that does sound good. Is that all right with you, Aparajito, if we well, we have one question from Sarah, which I'll read just a moment, and then we'll head over to Aparajito for the parts of an astrophysics journal. Then we'll come article, and then we come back to you, Philip, to finish that. Does that work for you, Aparajito?
He's busy answering questions.
I'm sure he's busy answering questions in Slack. Okay, so let's move to Sarah's question. Is it possible to divide strings, Philip?
Right. So when you say divide, you mean you want to split it at a
Split
certain
them.
location.
Yes.
Yep. And that can be done. Notice again, essentially what we needed to do was find the word that we need. So if you do S dot and then you type out the word, there you see there's a word, there's a function called split, a method called split. Everyone can see this, right? And sometimes these little pop-ups don't show up when I share my screen, but Jamika,
Yeah, the
can you see the
pop-up
word
is showing.
Yeah,
Sure is. Thank you.
So you have the words split. You can also have swap case, which I'm guessing is the answer to the previous question, but about how we can change uppercase to lowercase and so on. But split, let's look at what split does. And again, I put this question mark at the end and run this and see what it does is it splits a string into a list of substrings. We haven't gone into what a list is. I'm going to be talking about that soon, but it's going to give you a set of substrings using some sort of separator. Okay, and the separator is the option that we're sending in here. By default, there's no separator, but we could, for example, split a string based on a separator like a comma. So let's actually check that right now, because you notice that S is hello, comma, world, and therefore we could try and split it based on this comma. So we could break it into two different strings. by just saying set equals comma. And if I run this, you see that I've taken the string hello world and I've broken it into two parts, one part that's hello and one part that's space world. Remember that Python doesn't quite understand what these strings mean. It just recognizes them as a list of characters. And so it's breaking them exactly at the comma, and everything that's to the left of the comma is taken into the first string, and everything that's to the right is taken to the second string. Now, this actually segues quite nicely into the next part, which is on lists. So this object that you're seeing here right now is a list. And you notice that it's a list because it has these square brackets on either side, and it has a comma. So it has a list of different elements, one after the other. And each of these elements is a string, first one being hello, and the second one being word. Jamika, Prajito, whenever you're back, Prajito, just let me know, and we can move on to the structure of the astrophysical journal. In the meantime, I'll move on to talking about lists. I can stop midway.
Sounds
Okay,
good.
yeah, I'm here. I can take
fantastic.
over
Yeah, so
anytime.
if you can explain the structure of the astrophysical journal, then I'll come back
Okay.
and do lists. Fantastic.
Sure. Give me just a minute. Let me just open up the PDF.
Sure. Any other questions in the meantime? If anyone has any questions, I could try and answer them.
No questions that I see right now,
Okay.
but
So here, for
anyone-
example, let's say you're annoyed by the fact that there's a space here. You want the word hello and the word world to be separate. So one thing we could try is to put a space in the separator as well. So if I run this, you see that the space is disappeared from here because it reads comma and space to being the separator. So it takes that entire region of comma and space and separates everything to the left of that, which is the word hello, and everything to the right of that, which is the word world. So I'm going to stop sharing now, and I think Aprajito is going to start sharing, hopefully. So, and then I'll be back in about 15 to 20 minutes.
Thank you so much, Philip.
Yeah, okay. I hope you can see my Chrome window. And the PDF with a lot of text inside. Yeah, hang on, give me just a second, I think. I should turn on my camera. In the meantime, if you have any questions, please post them to the Slack channel. Okay. Right. Hello, Drew. So this is the paper that this entire tutorial is based around. This is a paper by Claire Dorman, Raja's former PhD student. This is a paper, as you can see, on the Andromeda Galaxy, on the Andromeda Galaxy's stellar disk. So the part of the Andromeda Galaxy that contains stars. And basically, this paper studies the velocities of different kinds of stars and how much variation there is, how much, how spread out the distribution of those velocities are. And through it, this research tries to understand the history of the Andromeda Galaxy. Because it's a very old galaxy, it's been around for a long time, and there have been many collisions in the past. We'll learn a lot more about this astrophysics part of this project, of this tutorial tomorrow. There's a whole section dedicated to it. But for now, let us look at the paper itself. So, what is in an astrophysics paper, or rather any research paper in general? There's an abstract at the very beginning. This abstract is a salient feature of any research paper. An abstract is basically a summary of the entire paper. It contains a very brief introduction and a rundown of the results, a rundown of the methods, a rundown of the results, and a couple of lines on the conclusion. It ties everything together into this one compact paragraph. You can just look at this abstract and decide if this paper is relevant to your work, if you should read it, or what you are looking for in that paper. Because papers are very long. If you're interested in a certain aspect of the paper, say you're only interested in the methods, or you're only interested in the results, you can get a clue about that from the abstract. The abstract is like a trailer to the movie, right? Except it's paused and because we're not worried about that in research, I guess. And then there's always an introduction. Okay, so introduction is where you introduce the words, as the name suggests, you introduce the reader to the topic of this paper. You give them a basic rundown of the object or the very specific topic that you're working with. And please note that if you read this introduction, you'll see that some of it will make sense to you. If you're a beginner to astronomy, if you haven't read a lot of astronomy papers, you'll see that part of this makes sense to you, but a lot of it will not, because research papers are first and foremost written for other researchers. So it assumes that you have a certain degree of familiarity with the basic topics being discussed. And then it builds on that. Yes, Shamik.
Quick question from the chat. Just trying to get a good understanding here. Is this paper talking about how the increase in average star velocity from the galactic center to the edge of the galactic disk is much more for the Andromeda galaxy than for the Milky Way?
I will not answer that, because that we are basically going to study this whole thing over the next 2 days. So you're actually going to run the code that was used to create the results in this paper. You will generate maps of velocity dispersion. You can actually see how the velocity dispersion changes from near the center. I don't think we take data from the exact center of the Andromeda, but somewhere near the bulge, all the way to the edge of the galaxy. And maybe you can then compare it to similar data from the Milky Way. But also, it's a bit harder to measure because because we're looking at the Milky Way from the inside. We are within the galactic disk of the Milky Way. We're looking outside, looking through the Milky Way's disk. The Andromeda, on the other hand, is a distant galaxy. Well, not distant in terms of cosmic scales, but it lies outside our own galaxy, right? So you can actually look at the whole galactic disk and study these things, and maybe get a better insight into how our own galaxy works. So stay tuned. We will explain all the astronomy. This section is only about the structure of the research paper. By the way, Raja, I see you here. Please feel free to jump in if I miss anything.
No, this is great. I didn't. Tomorrow, hopefully, if there's a window tomorrow, I can. I'll look at the exact schedule. I might be able to show you some interactive stuff on Andromeda. But this paper is something I'm very proud of. Claire Dorman was my PhD student. More importantly, it was really Claire's idea that you could take actual code and break it down this way into a tutorial. That is, the actual code used to generate these plots. You could remove lines of code and leave the comments in there. That whole pedagogical technique is something that Claire herself came up with. And it perhaps is not a surprise that Claire was homeschooled as a high school student. didn't go to a formal school with structure, so was homeschooled, and both her parents were high school teachers, but she really had tremendous pedagogical expertise. Anyway, shout out to her for making this tutorial possible.
Hi. Yeah, but like Rajesh said, this paper is the basis of this entire tutorial. You're actually looking into how a paper is written. Of course, this work was probably done over many years. You will get a full rundown over 3 days. But yeah, that's the long and short of it. Anyway, the introduction, like I said, as the name suggests, introduces the reader to the topics of the paper. And you can see that there are many subsections which introduce each specific topic at a time sometimes. And you'll find diagrams like this scattered throughout the paper, depending on what kind of paper you're looking at. So obviously, a STEM paper will have plenty of diagrams. On the other hand, say, a literature paper might have none, all right? So once again, that depends. There are many kinds of graphs, many kinds of plots that you can see. You will learn how to make these plots. The next section is called data acquisition, right? Data acquisition describes how the data was collected, which is, once again, might be a part of some papers in some fields, but might not be a part of papers in other fields. For example, if the work is theoretical, there might not be any data collection, right? So you won't have this section. But we are doing observational astronomy, so there is a section on data collection and reduction, which is basically getting rid of all the extraneous stuff, all the noise and stuff from the data, and extracting only what is needed. That is called reduction. And section 3 is methods. The methods are basically how all the results were generated, what we did with the data once we had it. Yeah, I had mistakenly skipped to this section while I described the introduction, but you can see that these subsections are actually part of the methods. Once again, you can actually see the breakdown, the different parts of the method. The whole workflow is described. It is very, very important to describe the methods very accurately, because the entire basis of research is peer review, right? So other researchers should be able to look at your paper and know exactly what you did, right? And they should be able to reproduce the exact same results given the same data using these methods, okay? So it is very, very important that you describe your methods accurately and completely, okay? And finally, there's results. You will see this plot sometime tomorrow, probably. And you'll also create these plots. The results usually contain the most plots because visual representation is a very, very easy way, it's a very convenient way to convey a lot of information very efficiently. And finally, there's the discussion or conclusion portion of the paper, which sums up the results, explains what we can learn from these results, and potentially how we can build on these results for future work. And finally, there could be a summary. This is not, again, this is not something that you can find in all papers, but please note that all papers always end with a list of references, okay? There's a list of references. This refers to other peer-reviewed papers, peer-reviewed studies that support your work, that supports the conclusions, the statements that you make. in your work. And you can see that throughout this paper, there are citations, right? There are parentheses. There are many ways to cite a paper. Depends on the journal, but it is the name of the authors and the year when it was published. And you can see that this whole paper is scattered with these references. And if you click on one of these, it will take you to the references, right? It will take you to the list of references and point to the exact one, right? So, and at the very end, this appendix, the appendix contains, whatever extra table or data, whatever you couldn't fit in there. So to sum it up, this is a research paper of observational astronomy. This is roughly the structure that many research papers follow in many different fields. There might be slight variations, but basically it usually goes abstract, which is a summary of the whole paper. It is like a trailer to the movie, introduction that, like the name suggests, introduces you to the topics of the paper, data acquisition and reduction, which tells about the data reduction, how it was collected, when it was collected, methods that describes the exact methods that you applied on the data, all the stuff that you put the data through, results, what you got after putting the data through those methods, through those processes, and finally, discussion and conclusion, optionally a summary, but very importantly, a list of references, and maybe an appendix. Yeah, that's it for the research, for the structure of this paper. If anybody has any questions, please go ahead and ask.
For Prajit, I was just going to chime in to say that there are a couple of workshops that we'll offer in SIP. One next week is just about introduction to open-ended research, but there'll be a couple of other workshops, one on reading and writing papers and one on giving talks. So we'll cover some of this, sort of storytelling aspect of science. How do you communicate? How do you take in other people's communication of science? We will cover that. Thank you.
Thank you so much,
Yeah,
Aparajita.
by the way,
yeah,
I've
sorry.
just shared the link to the paper in the chat. Yeah, I'll also share it in the Slack space. So, if you want to check it out, it's available for free, at least on archive. Yeah, over to you, Jim.
Thank you so much, Aparajita and Raja. And in the chat, Anand has put information about the SIP workshop that Raja was referring to. Okay, Philip, back to you to wrap us up with notebook 1. Oh, sorry, we can't hear you.
Right. So shall I take over screen share or how does
Yeah,
this work?
yes, please. Yes, you can do that.
Yes, I can do that.
Thank
Fantastic.
you.
Great. So can everyone see my desktop?
Yes, we can.
Yeah, perfect. Perfect. Just give me a second. Okay, great. So, oops, just a second. I don't like the zoom bar. Okay, great. So where were we? We were at lists. We were starting to talk about lists, and this is going to be very important. And the reason it's going to be very important is because we're often going to deal with very large amounts of data, and we don't want to keep assigning them to variables. We're going to run out of alphabets if we start doing that. We're going to get huge numbers of data. And so ideally, what we would like to do is have a sequence of objects, a list, which is a large number of objects. And you'd like to sort of select out different elements of those objects by using, say, a number or something of that sort. And so we do that by defining something like a list, which is what we do down here. So I've defined the list in the variable x. And I know that it's a list because I put it within these square brackets on either side. And the list has 4 elements. They're the elements 0, 1, 2, and 3. And they're separated by commas in between them, right? And now I could print the entire list. So I'm just going to comment out these lines. I can comment out multiple lines by just selecting them and pressing Control and slash or Command and slash if you're in a Mac. And if I run this right now, it's just going to print out exactly the same list. It's going to print out 0, 1, 2, and 3. But now, let's say I just want to print out first element of this list. Now notice the first element of the list is basically the list name. Then we have in square brackets the number 0, because Python, as we say down here, in Python, we start counting indices from 0. So the first is what we're actually talking about is the 0th element, first element, the second element, and so on. So the earliest element in a list is the 0th element of the list. And we get that by writing the list's name and then using 2 square brackets on either side and putting the number 0 in between them. So that means take the 0th element of the list and print it out. So in this case, the 0th element of the list happens to be 0. And so when we run this, we get the number 0. And we could, of course, do this for all the other elements. And then we'd see that the first element is 1, the second element is 2, and the third element is 3. So the 0th element is 0, then 1, then 2, 3, so 4. Of course, we could have a different element here. We could start off by saying 23, 24, 25, 25, and 26. And if I run this, then it's going to print the entire list here, 23 to 26, and then it's going to write 23, 24, 25, 26. And if you run this, you can see exactly what happened. There's no reason for these elements to be ordered. I just chose them to be ordered. So you could, of course, write 22, 299, and 0. And if I run this, you'll see that it takes every element of the list and it prints it out in the appropriate order, one after the other, right? So this is just putting down what we can do with these different lists. But lists also come with their own inbuilt functions. So one of them is the length function, which is going to be a useful function. And it's going to tell you how many elements the list has. And it's done. And you can do that by just printing out len. And we write, since it's a function, whenever we have functions, we use these little round brackets. Whenever we want to look at the element of a list, we use square brackets. So that's an important distinction to make. So don't try to use x with round brackets around it. But whenever we have some sort of function, like the print function or the length function, we put whatever the argument of that function is, in this case, the entire list. And if we put that within the length function and we run this, it's going to say, okay, this list has 4 elements, 0, 1, 2, and 3. And so it's going to say the length of x is 4. Okay, so it's the number of elements that x has. And remember that even though the list has 4 elements, since we're starting counting from 0, we can only do x of 0, x of 1, x of 2, and x of 3. Now, I would like to also just print out, or at least try to print out, x of 4. Now, notice that there is no x of 4 here because x only has 4 elements. And so 0, 1, 2, and 3, and the 4th, there doesn't exist anything here. So if we try to do this, it's going to throw an error. So if you run this, and indeed you see that the list index is out of range. In other words, we're trying to call the 5th element, or in other words, the 4th element of a specific list, and the list doesn't have that many elements. So that's going to throw an error. So you don't want to do. But of course, we could, if we had a very, very long list, let's say a list of 1,000 or 5,000 or 100,000 entries, and we want the last element of the list, we don't want to have to write 1,000 or 10,001 or 10,005, some large number like that. So sometimes we might want the last element or the second to last element or the third to last element or so on. And in this case, we can actually start indexing the list using negative numbers. So in other words, if x of 0 was the first element, then x of -1 would be the last element. X of -2 would be the element just before the last one. So if we run this entire bit of code right now, you'll see that it's going to print out the last element of this list, which is 0, then the second last, which is 299, and then 22, and then 23. If you run this, indeed, you'll see that's exactly what it does. It prints out 0 first, then it prints out 299, then 22, and 23. Okay. You can also get out different slices of these lists. You could take out elements. You could print out, for example, x from element number 0 to element number 2. In this case, element number 0 is 23, and element number 2 is 299. And so we could actually print out those elements in here. So let me just comment out these lines and just run that. And you see that it takes out 23 and 22. Because you've asked for every number starting from 0 and ending at 299, and it does not include 299 in this, right? And if I did 0 to 3, you'd notice that 299 would come into this. So if I add this now, you see it's 22, 22, then 299. We could also just remove the 0 because we don't really care about this. So the 0 is just there to make things clear. But if you just did :3, then it'll implicitly assume that there's a 0 if you don't put in anything. Yeah, and that's exactly what's happened. You see, there's no difference between these two lines. Their outputs are exactly the same. Similarly, you could just put x1 and then a colon, which would mean that it would take the first it would take everything from the first element of the list up to the end of the list. In this case, our list goes, so it would ignore this element and then we go to 22, 299, 0. Let me run that down here. It's 22, 299, 0. And you can also do very fancy stuff. You could also try to slice with negative numbers. And if you try this, what we're going to do is we're going to take every element up to the second to last element of the list. In other words, we're going to go from the start, which is 0, and then go to 2 elements away from the end of the list, which is 299. And then we're going to print that out. And that gives you 23 and 22. So this is exactly the same sort of notation in our case right now as this, but that's because our list has 4 elements. We'll come back to this in a little bit more detail later on. So I'm not going to go into great detail right now. But we're going to see how we can manipulate elements of the list just like we can manipulate variables themselves. So for example, we could start off by assigning this particular list x to be the variables 1, 2, 3, and 4. And then we could just change one of the elements of this list. So in this case, we're not going to touch the 0th element, which is 1. We're just going to change the first element, which is 2. And we're going to put in the value 486.1. Okay. And you'll notice if I run this, that the original list was 1, 2, 3, 4, but the new list is 1. And then instead of 2, we have 486.1. And then the other elements remain untouched. So we get almost the same list, except for one element changed in that list. Another important thing to realize is that lists are actually very, very powerful. They don't need to have only numbers. We've so far used only numbers, but they can have numbers, they can have strings, they can have other lists inside them as well. So you could just run this entire cell and you see exactly what it's doing. It's behaving the way you would intuitively expect it to behave. If you asked it to print A, it would just print out the entire list. If you wanted it to print A of 0, it would print out the number 1. If you wanted A of 1, it would print out this particular string. And if you wanted A of 2, it would print out this particular list. In the last step, we noticed that we can also print out, this list can be indexed by 2 indices. In other words, since A of 2 is this particular list, we could get the 0th element of this particular list by using 2 square brackets. So this would mean get this particular list, and this would mean get the 0th element of this particular list, which is the number 1. And if I change this to 2, then it would take the 0, 1, 2th element, which is 3. I'm going to run this here. You see that it's changed the last line and made 3. Okay. So there are many different ways of manipulating these lists, but I don't think I'm going to go into them in great detail right now. So I think I should just move on, if that's okay, Raja. And people can come back to this and look at it when, this is more a reference. So this is a very, very large notebook. So you can go back to this. It's all completed. You can run through it and learn more about how to manipulate these lists. But I'm just going to go and talk a little bit about functions. And then after that, I'm going to go into the next notebook, if that's okay.
That sounds good to me, Philip. That sounds like a good plan.
Right.
Yeah, everybody please download the notebooks. And just a reminder that the first 2 notebooks, notebook 1 and 2, are completed even within the empty notebooks folder. So, this is exactly the notebook you will get when you download them. And you can see that there are helpful descriptions all around the cells. So please run them on your own and figure them out. Yeah, over to you, Philip.
Okay, so I should talk a little bit about conditionals first, because I think this is also going to be very important for us in later notebooks. And so these conditionals are basically, we want our computer to make decisions at some point based on whether certain conditions are true or false. Let's first understand how we'll define conditionals. And the first thing to realize is that we can actually store what we call Boolean variables, which are variables that can be in one of 2 states, either true or false. And we can try and combine them together using different operators, the AND operator and the NOT operator. So A, in this case, is the Boolean variable true, and B is the Boolean variable false. And now what I can try and do is I can do A and B, okay? And so if I don't know how many people are familiar with Boolean logic, but if I try to do A and B, that's effectively trying, it's trying to find out if both A and B are true at the same time, okay? And in this case, you'll see since A is true and B is false, A and B would be false. Okay? Similarly, if we try to do A or B, then what we're trying to check is if A is true or B is true. And in this case, since A is true, the answer would in fact be true immediately. Good. And that's what we get down here. And of course, we can do other operations, which are like the NOT operation, which converts a true to false and a false to true. So if I just tried to print not A, I would get, since A was true, not A would give me a false. So let me actually, just to make sure this is clear, let me just write out A and B is equal to this. Sorry. A or B is equal to this. Not A is equal to this. Now we could also have not B as well. And since B is false, not B would be true. And if I now printed out not A, comma, not B, it would print out first false because A was true and therefore not A is false. And B was false, therefore not B is true. So it prints out these two values. Okay. So let me write that out here. There we go. Oops, forgot a comma. Great. So you get these different values. And now we can use these comparisons and these Boolean operators to perform some tasks. First, let's check some simple things. So now, of course, when you want to check whether a number is equal to another number, you can't use the equal to symbol because the equal to symbol has already been used for assignments like this, like A equal to true. So to check if something is equal, then you need to use two equal tos right next to each other. Okay? So we're going to print out, for example, 1 equal to 2. This checks if the number 1 is equal to the number 2. If it happens to be equal, then it's going to print out true. If not, it's going to print out false. So let's run this. If I run this, you see that the first line gives me 1 equal to true is of course false, and therefore it prints out false. The little exclamation point here means not equal to. So this entire symbol, just as this symbol was, is 1 equal to 2, that's what this sentence means. So this particular sentence means is 1 not equal to 2, and that's how you should read it. And what this does is it takes the number 1, it compares it with the number 2, and if they're not equal, it's going to print out true, and that is the case, right? Similar to equalities, we can also look at inequalities. In other words, is 1 less than 2? In this case, this should give me a true result. Is 1 less than or equal to 2? Yes, that is also true because 1 is less than or equal to 2. And we see that both of these statements print out true. We can similarly try the same thing, which is 1 greater than 2 or is 1 greater than equal to 2? And you should see that in both these cases, we get false. Okay. So the good thing about these conditional statements is that we can actually use something called an if statement, which only performs a task if a condition happens to be true. Only then should we do something, right? So that's what we're going to do right now in this particular cell, which is, let's say that we have a variable that's called x, okay? And x is initially given the value of 5. So if x is greater than 10, I want to say x is greater than 10. If not, I use the else condition here, and I print out x is less than or equal to 10. Now you notice that the syntax here is a little different from the syntax that we've used so far. So let's start off with the first slide. This shouldn't be anything confusing. You've already seen us assign variables before. But now what we do is we say if x greater than 10. Now I'm just going to add a little cell above this, just a second. There we go. And what I'm going to do here is I'm going to say x equal to 5 and print x greater than 10. And obviously, since 5 is not greater than 10, it's going to return false. And so if 5 is greater than 10, will return false, and therefore this statement will not be printed. Now, what we want to do now is to say that every line that's inside this if statement should be indented rightwards and should end with a colon. So I'm just going to explain this very, very slowly. I think I might have done this a little too fast. So I'm just going to work through this very, very slowly with all of you. So I start off by saying x is equal to 5, and then I say if x greater than 10, and then I put a little colon. And now when I put a colon, Python understands that everything that's within this colon, underneath this colon, has to be tabbed in, and that means that it'll be run if x is greater than 10. Then I'm going to print out x is greater than 10. So now let me just run this statement as it is. And you notice that it doesn't produce any output. That's because x is not greater than 10, and therefore nothing is printed out. Now we can, of course, put an else here, which means run the else in case x is not greater than 10. Again, I have to put a colon, press an enter, and then I say print x is less than 10. And now when I run this, it tells us this is not true. Therefore, it's going to run this statement and say x is less than 10. Now, the point of this indentation is that you might want to print multiple statements. And I could say x is less than 10, and I could say, let's just say the same sentence again. If I run this, you see that this statement is run that many times. It's going to run it's going to run anything else that I write down here. I can also write out the word hello, and it's going to run it's going to run this. On the other hand, if I changed x to 15 and I ran this again, then what's going to do is it's going to check, and 15 is greater than 10, and therefore it's just going to print the number 15 is greater than 10. So these are how we could use different conditional statements to perform different tasks. And we can add multiple conditions like this using the elif command, meaning it's short for else if, and then have multiple commands chained one after the other. So let's say x is equal to 10. Then what we do is we say if x is greater than 10, print x is greater than 10. Else if, or elif, x is greater than 0, print x is greater than 0 and less than or equal to 10. And if neither of these things are true, then print that x is less than or equal to 0. And in this particular case, since we have 10, you should be able to see that since 10 is not greater than 10, this is not going to run. However, 10 is greater than 0, and therefore this one is going to run. And so we're going to see that x, which is 10, is greater than 0 and less than or equal to 10. If we run this, you see that that is in fact get done. Any questions so far? Have I moved through this too quickly, or are people able to follow? Okay, so no questions. So that's either a very good sign or a very bad sign. We'll see. Okay, so now
you're doing great, Philip. You're doing great.
So we could also, I don't think I'll go into loops right now. I'll go straight to functions, and then I'll go to the second notebook. So you guys can go through these remaining sections that we have in this notebook, and you can ask us questions on Slack. I'm sure we'll all be happy to answer.
And Philip, I was just going to add that students will see examples of Boolean variables, loops, conditionals, all three of those, and sometimes combinations of these three things in the, not in notebook 2, but in notebook 3, 4, 5, and 6 in the astronomy context. In particular, there's a particular block of code in the last notebook, in notebook 6, that combines all three of these things: loops, conditionals, and Boolean variables, Boolean arrays even. So it's not the last time you're seeing this.
Yep. Okay, so now we're just going to go into functions. So we've already seen some functions. We've seen functions like print, length, and so on. But we'd like to define our own functions to do different things. So let's say we want to find the norm or the distance between, or the length of a certain, like, vector in space, so something of that sort. Let's say I want to perform some sort of complicated mathematical operation. So I want to take x, square it, and then I want to take y, square it, and then I want to take the square root of the sum of these two numbers. And I want to keep doing this again and again. So I don't want to have to keep writing this every time. So it'd be useful for me to define a function that does this for me. And then I just need to call that function with certain variables, and it would repeat this action many, many times. So in order to do that, I will define a function by using the define function name option. So I would type out, so let me just define def, a function. So let's say norm. So I'm just going to rewrite what I've got down here, but I'm going to build up how it's being written. And then I'm going to say that this function accepts two parameters. So I could call it x and y. So you need to, if you ever call the function norm, you need to send in two parameters. Okay? And then what it's going to do, Again, I put a colon and I press enter, and whatever is tabbed inside this region now is going to be part of that function. Okay. So now I say, okay, I take x and I square it, and then I add it to y, which I also square. And then I take the square root of both of these things by raising it to the power 1 by 2. And I store this inside a variable, which I call, say, n. Okay, so what does this mean? Remember, you read right to left. So you take x and square it, then you take y and square it, you take the sum of both of those numbers, you take their root, and you store it in this variable n. And now what I want the function to do is whenever it's called, I want it to return the number n. So I can just type out return n here. And you see that's exactly what we've done in this section of code here. Right? So now if I do this entire thing, and it's been done for me, and I call norm with the number 4, and what this is going to do is it's going to take the number 4, plug it into this function, take 4 square, which is 16, and it's going to take the number 3 and take 3 square, which is 9, and you add them together, you're going to get 25. And then when I take the square root, I'm going to get 5. And then it's going to return the number 5. So I've performed a complicated mathematical operation. And now if I run this, you'll see that the first case gives me 5. The second case is where I take the number 1, which I square, and it gives me 1. Then I take the number -1, which I square, and which also gives me 1. And when I take the square root of this, I get the square root of 1 plus 1, which is the square root of 2, which is in fact 1.4142. So now if I ever want to compute this sort of quantity, x squared plus y squared under root, I don't need to keep writing this complicated piece of code. I can actually just call the function norm. And we're going to see how to use functions many times because it's going to make our life very simple. It's going to allow us to take a small bit of code, which we're going to keep needing to use again and again, and just save it somewhere with a certain nickname, and then just call that nickname regularly whenever we want to use it. So there are some other examples of functions down here, which are a little bit more complicated. I'm not going to go into that right now. Instead, in the last 10 minutes or so, I think I'm going to try and work through the second notebook, right? So I'm going to move into the second Python notebook. Can anyone tell me whether you can see this notebook right now on my screen?
Yes.
Jamaica? Okay,
Yes, we
fantastic.
can definitely
Yes.
see that. We
Okay.
did have a question that just came
Sure,
up,
sure.
but I really quickly, when you use return, does it allow you to store the function's output into a variable? For example,
Yes.
yeah, you got it.
Yes, exactly. That's exactly what you can do. So for example, let me just quickly do that. Where is it called? We can just quickly do that right now. So we can say some norm is equal to norm of 5 comma 3. And then when I printed out some norm, then it's going to print out the norm of 5 and 3. It's going to give me this number that's close to 6. Is that clear? Yeah. Should be fine. Great.
Philip, if you
Yes.
put in a Pythagorean triple, that might be easy for people to. I
Yes,
guess there was
that's a good
one
idea.
earlier on.
There was one earlier as well. There's 4
Yeah.
and 3.
How
But
about
this is
5 and 12?
5 and 12. Yes. So you do 5 squared plus 12 squared under root and get 13 squared. And 13. 5 squared plus 12 squared is 13. That's great. So now in the second notebook, we're actually going to start doing. So you see that we've defined the function here, for example. This was the function norm, and we need it. I mean, for those of you who are a little familiar with mathematics, you know that you'd recognize what this formula was. It's just taking x squared and y squared. So if you had a right triangle with lengths x and y, then the hypotenuse would be given by under root x squared plus y squared. So this might be a useful thing if you're using for mathematical reasons. But we also have a large number of predefined functions that are already defined in these different packages. And so in this particular notebook, what we're going to do is we're going to import a couple of packages that we're going to find useful. Okay. The first package that we're going to import is a package called NumPy, and this should come installed. If you've installed Anaconda, this package should come pre-installed with Anaconda. And what we're doing in this line is we're importing all of this package, I mean this NumPy package, and we're giving it a nickname NP because sometimes it gets a little tedious to keep typing NumPy whenever we want to use functions that are within NumPy. And so what we're going to do is we're going to import NumPy as NP. And what that does is that if we ever use NP later on, and we call a function that's within NP, then it's basically going to look inside NumPy and find the function with that appropriate name. Then we're also going to import a more complicated package called matplotlib, which I think I should come back to a little bit later. So I'm just gonna comment out this line right now, and I'm just going to deal with the NumPy package first, right? So if I run this, you'll see that it just runs. It doesn't provide any output, and it imports the NumPy package and gives it a nickname NP, right? Now, NumPy has a lot of very nice inbuilt functions that we're going to use. So one function that we're going to use is the arange function, which takes a range of numbers, say 0 to 100, and it takes a spacing between these two numbers, 0.5, and it produces an array of such elements. So I'm just going to show you what that does. So let's say you're confused by this function and you don't know what it does and you don't remember what it does. What you can do is just do an np.arange, just like I did down here, and put a question mark at the end. And you see that it gives you a list. It tells you what this function does. So it says it returns an evenly spaced list of values within a given interval. Okay. And so you could have, so over here, we've taken an interval from 0 to 100, and it's going to give you a list of elements whose spacing is 0.5. So that's what these three elements mean. This is the start, this is the end, and this is the spacing between these different elements. So again, just as before, I'm going to try and print out X. And if you print out X here, you can see that X has all of these different elements here. It has 0 all the way to 99.5. So it doesn't include 100 right at the end. And you can also print out the length of X, the mean of X, and so on. Now, these are all inbuilt functions that are within the NumPy package. So length is already a Python function. But let's say you wanted to find the average of this list. So you could use the np.mean function. If you wanted to find the maximum value of this array, which obviously will be the last value, 99.5, you could use the np.max. And if you wanted to find the minimum value, you can use the np.min. Notice that the dot sign basically means that you use the max function as defined in the NumPy package. Okay, so if I run this right now, you see that it takes the numbers 0 all the way to 99.5. The length of X is 200 because you have 200 elements, because the spacing between each of these elements is 0.5. The mean, the average value, is 49.75. So what it's done is it's added up all of these numbers and divided by 200, which is the total number of elements. The minimum value is 0, it's the first element here, and the maximum value is 99.5. Does anybody have any questions based on what I've done right now? Or is this clear? Any questions in the chat, Jamika? No, it's fine. Okay, great.
Yeah, no questions right now.
Okay. So this is one of the inbuilt functions in NumPy, which is to get a list of elements that are equally spaced between each other. And we can also have other functions which find the average of a list, of an array, which find the maximum and the minimum of an array. But similarly, we can also do other things. We can perform mathematical operations to an entire array of elements. But let me just talk a little bit about how these NumPy arrays are different from lists, maybe just for a minute or so. So if you remember, if we had a list, so let's just call it a list, my list, and I give it the elements, say 1, 2, and 3. Okay? And I can also define a NumPy array by just taking such a list and putting it inside this predefined function called np.array. I'll just write 1, 2, and 3 here. Okay, so now I have two objects. I have a list 1, 2, and 3, and a NumPy array with the same elements. So if I try underneath this to print my list, it's going to give you the numbers 1, 2, and 3. And if you try to print my array, it's going to again give you the numbers 1, 2, and 3. There's slight cosmetic differences. You'll notice there aren't any commas here. But in many ways, it seems like these are exactly the same. So if I tried, for example, to print the 0th element of my list and the 0th element of my array, they're both going to be 1. But the difference between these two objects comes when you try to perform mathematical operations. So let's see what happens when we take a list and we multiply it by the number 2, right? Now, if we take a list and we multiply it by the number 2, what we're going to get is this. So it takes the list 1, 2, 3, and it makes a copy of the list and adds it at the end. So it duplicates the list. It doubles the same list of elements. And you might be surprised by this because this is not really what you might want to do with a list of elements. Maybe what you would want to do, which is what we would want to do in physics in general, is whenever we want to multiply an entire array of elements by the number 2, we want to multiply every element by that number. Okay, and this is discussed in some detail in the previous notebook. But if you notice that underneath, if I type out print my array and multiply it by 2, in this case, it does at least what I would expect it to do, which is take every element of the list and multiply it by the number 2. Okay? And so these NumPy arrays are much more useful for physics and astrophysics because they do the sort of things that you would expect these arrays to do. They behave like vectors. If you're comfortable with vectors, these quantities behave like vectors. Yes, Jimmy.
We're coming up to the top of the hour, so I just wanted to give you a time check so that you could find a good stopping spot. And then we did have a few requests I'd like to share with you before we end.
Fantastic. So I think what I'll do is I'll just finish off at this cell right now, and then maybe at the start of the next session, we can move on to just the rest of this notebook. Would that be okay?
Perfect.
Okay, so just right at the end, right down here, so the last thing that we're going to do is that since this array X happens to be a NumPy array, we can actually do an interesting set of manipulations on it. So NumPy has its own set of functions that can do more complicated mathematical. So for example, we could find the sine of a number. We could find the cosine of a number. So let's say I did np.sine of, say, 0. Right, for example, and I printed this out, and it would give me the sine of the number 0. Okay. But let's say I had a list of an array of different elements. I could find the sine of that entire array as well. And I would do this by just doing np.sine of the entire array down here. And if you run this, you'll see that since X is an array with 200 elements here, np.sine will also be an array. An np.sine of X by 10 will also be an array with 200 elements, and np.cosine as well. And if you run this, you should be able to see that y1 and y2 will now have variables that are given by the array x1. For each of the elements of x1, it would take x1, divide it by 10, and then take the sine of that number. So we're going to write that down here, and I'm just going to print out the value of y1. And you see that the value of y1 has many different values. And let's print out the length of y1. See that it has 200 elements. And the same thing is true for the array y2. And they have the same number of elements as X, because what NumPy has done intelligently is that it assumes that what you mean is when you write something like this, where you write np.sine of an array, is to apply the sine function to every one of the elements of that array and return it. So I think I'll stop here, and then we can go on to the figures and other things in the next session. So Jamika, do you have any questions or?
First, I'd like to say thank you, Philip, for running these notebooks, for leading these tutorials today for notebooks 1 and getting us started into notebook 2. It's wonderful. Raja, Aparajito, Lordrick have been amazing. Thank you all so much. And of course, in the chat, in the Slack chat, the discussion area, Lordrick and Aparajito have really been connecting with everyone and trying to get those questions answered. So we're so absolutely grateful for that. So Philip, a quick question about your notebook 1. We have a request for your specific notebook. Could you share that in the Slack for us so that we could get your notebook 1 from today? Oh, we can't hear you. Okay, excellent.
Yes,
thank you so much.
I will share that on Slack, right, just after this is done.
Excellent. Thank you all so much. And so tomorrow we'll start at the exact same time. And again, remember, one of the benefits of Slack is that your questions stay there, your screenshots, everything you share will stay there. So please come on over to the Slack channel, get the download to Philip's notebook, and interact there afterwards for any additional questions you may have had about what we was covered in notebook 1 and as we were starting to get into notebook 2. Thank you all for the amazing engagement in the chat today, and getting lots of thank yous to everyone. Raja, would you like to say anything to close this out?
I have to hop off to a different Zoom call. I've invited all
right.
the Astro interns and mentors to join that, so I'll be on that one. So if you please come on over there if you want to chat. So this is
Okay.
I've sent that to the astronomy, the SIP 2024 AST mentors, interns, and our collaborators. So I'm going to hop to that one.
All right, sounds good. And then there's a quick question, Philip, is there anything we should do before tomorrow's session?
That's a good question. I think just go through notebook 1 again. So this time we've gone through it like with me writing it out, but it'd be nice if you guys could actually try it out yourselves and, fool around with it, try to change different parameters, see whether you can learn what you can. Just get comfortable with using all of these bits of code because we're going to start doing more and more complicated things in the next few sessions.
Excellent, excellent. All right, well, we will
I completely agree with Philip. By the way, please join the Slack space because it is much easier for us to walk you through the installation issues. Like Philip said, please go through notebook 1 on your own. And I'd like to emphasize going over the loop section that Philip couldn't cover today. Please look at the for loop because that's the only one we'll be using. You don't need to understand while loop. Just look at for loop. That's all you need to do. Just get comfortable with it. Over to you, Jamika.
I've also shared the notebook on Slack. So
Excellent. Thank you so much. Thank you so much. I am so grateful to all of you for your time and expertise today. And thank you everyone for joining us, and we'll see you tomorrow.